Hey, good evening, everybody. Well, evening for me, morning for you, probably. So obviously, I'm not at school today. Unfortunately, my daughter woke up with a kind of a sore throat, non-COVID related, no other symptoms or anything, but she's got a really bad sore throat, so she needs me to stay home with her today. So unfortunately, I'm not with you guys today, but I will be with you guys tomorrow. Hopefully, I think my wife can take off if we need to, but I'll be back with you guys shortly. So here's what we're going to do today. So first thing that we're going to do is we're going to do a little warm up. So if you want to get out a piece of paper and do this, make sure you go ahead and do that warm up. You're going to pause the video and then I'll go over it. Second thing, I am going to go over the homework. So if you've not already done so, please get that submitted. Hopefully it was a pretty easy homework for you guys. And then the third thing, the last thing that we're going to do is go through section 7.3. You should get some guided notes for that if you haven't done so already. The sub should have them for you guys. Okay, so let's start by going over the warm-up. Go ahead and pause and do these problems. It shouldn't take you very long. So go ahead and do them and then unpause and see what you get. Okay, so for number 2 here, find the value of each power of 10. Remember that if it's a positive power, you write a 1 and this many zeros. 1, 2, 3, 4, 5, 6 zeros on the end of it. So it's a 1 million. If you're looking at 10 to the negative 5 power, remember that's a 0 point, and remember how many zeros, that this is the amount of zeros that are there. 5 zeros. 1, 2, 3, 4, 5 zeros total present. And then a 1 on the end. Okay. 10 to the negative 5th is 0.00001. Okay. Write each number as a base of 10, power of 10. So 10 to the 1, 2, 3, 4, fourth power. Positive 4 because it's a big number. See how this is a small number? I know that this is going to be 10 to the negative something. Let's get it back to 1. 1, 2, 3, 4, 5, 6th power, 10 to the negative 6th power, which only is confirmed by the fact that I see 1, 2, 3, 4, 5, 6 zeros there. Okay. Taking a look here, find the value of each expression. Remember when I say find the value, that means put it into, just extend it out a little bit. So we've got, I've got 650.3, and I'm going to move that decimal place 6 units to the right because it's a positive. So here's 1, here's 2, here's 3, here's 4, here's 5, here's 6. Here's my new decimal place. And I put in this many zeros, right? So my total amount is 6503 with 1, 2, 3, 4, 5 zeros. Okay, so that means I've got 300,000. Taking a look at the next one, I've got 48.3, and then I'm going to move that decimal place 4 units to the left now because it's a negative. 1, 2, 3, 4. Here's my decimal place and fill in my zeros. 0.00483. Now, again, you don't necessarily need that 0 in front of the decimal place, but you'll see me put it there. I think it just looks a little cleaner. And then the last one here, 92 times 10 to the negative third. Now, where is the decimal place here? It's right after the 2, right? So I'm going to move that decimal place 3 units to the left. Here's 1, here's 2, here's a third. So 0.092. That's my answer there. Okay. Now I'm going to go over some answers from the homework. So make sure that you have your homework out. And make sure you get it submitted as soon as you get it done, okay? Or if you haven't already done so. Number 14, that should be a 1 with 3 zeros, so a 1,000. Number 15, that should be 0.000000001. 9 total zeros, 8 to the right of the decimal place, and then a 1. Number 16, 0.000000000000001 should be 11 zeros to the right of the decimal place and 1 to the left. Number 17, that should be 1 with 14 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is a big number, folks. Okay, so that would be million, billion, trillion, 100 trillion, 100 trillion. Wow, that's big. Number 18, 10 to the negative second power. Number 19, 10 to the positive sixth power. And number 20, okay, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 total zeros. So it's 10 to the negative 15th power. Number 21, 9.2 times 10 to the fourth power is 9, 2 with 3, once 3 more zeros in the end, so 92,000. Number 22, it would be 0 point, and then I've got, move it once, I've got 6 more places to go. 1, 2, 3, 4, 5, 6, 1, 2, 5. Number 23, I'd move it twice and then 3 more times over to the left. So 0.123, 0.00042. And then number 24, I move it twice to get back to 5, and then I'm going to do it 5 more times to the right. So 5, 1, 2, 3, 4, 5, 500,000. Number 25, the human body is made out of 1.1 times 10 to the 13th cells. In writing it in standard form, that just means writing it out. So I've got 1 with 13 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 10 trillion? I think so. Number 26. At the beginning of the 21st century, the population of China was 1.287 times 10 to the, there's 3, 6, 9 places to get it there, times 10 to the 9th power. Number 27. In ordering from least to greatest, smallest is my lowest power. But now look here, I've got, I'm going to do this to separate it a little bit better, just so I can see the separation in there. Okay. It looks like the smallest value, I've got a 10 to the negative third, a 10 to the negative third, and a 10 to the negative third. So go with my smallest value here is 1.23. So 1.23 times 10 to the negative third. It goes away. And then I've got 1.32 times 10 to the negative third. That goes away. I've got 3.12 times 10 to the negative third. And those all go away. And now I've got 10 to the negative first, 2.13 times 10 to the negative first. I've got 2.13 times 10 to the positive first. And then I've got 3.12 times 10 to the second. And that goes away. Okay, so there's my order. Okay. Number 28 here. Donnell is allergic to pollen. The diameter of a grain of pollen is about 1.2 times 10 to the negative 5 meters, and 9, it's somewhere in between there, 1.2 times 10 to the negative 5th and 9 times 10 to the negative 5th. Donnell's air conditioner has a filter that removes particles larger than 3 times 10 to the negative 7th power. So will the filter remove the pollen? Well, for it to remove the pollen, it's got to be bigger than 3 times 10 to the negative 2nd. Well, is a power to the negative 5 bigger than a power to the negative 7? Like the value here, the value is bigger here. So yes, it will remove it. Yes, it will remove it. Because the pollen is bigger than, it will catch the pollen because it filters out the pollen. Number 30 through 35. We've got 4.008 times 10 to the, got 3, 6, 7, positive 7. Number 31, I've got 2.35 times 10 to the, and then it's 5th power. Number 32, 1.7 times 10 to the, this is 3, 6, 9, 11. Number 33, gets us, got to get it all the way back to the 6. This is 6 times 10 to the, and then we go back 1, 2, 3, 4, 5, 6, 7. So negative 7th power. Number 34, I've got to make it go all the way to 7.7 times 10 to the negative 1, 2, 3, 4, fifth power. Number 35, 4.12 times 10 to the 1, 2, negative second power. And those are all in scientific notation now. Okay. Number 36. 36 is not in scientific notation. So I've got to make it 5 times 10 to the... Now, if I move it one more place to the left, I've got to increase, right? I'm making a bigger number smaller, so I've got to be in negative 4. You know, you can think about it, if I wrote it out, that would be like saying 0.0012, 3 more left over, 0.5. If I wanted to put that back into scientific notation, that's 10 to the negative 4. 37, that is in scientific notation, so you don't even need to do anything with that one. Number 38 is not in scientific notation. That would be 1.2 times 10 to the 6th power. Number 39 is not in scientific notation. You know, if I wrote it out times 10 to the 3rd, that would be 250, right? 250. So really, it needs to be 2.5 times 10 to the 2nd power, not 3rd power. Number 40 is not in scientific notation. It'd be 1 times 10 to the, and then it's negative 1 power. Number 41 is in scientific notation. Number 42, 4.8 times 10 to the 4th power. And number 43 is in scientific notation. Okay. All right, so hopefully we did pretty good with the homework. You can ask me any questions that we have. Tomorrow is just another day going over section 7.3. So we're going to be, I'll have plenty of time to answer questions tomorrow, not only on the notes, but also on any homeworks that you may have. All right. Now, again, unfortunately, this is a hard day to miss because, for me, because this seems to be a difficult lesson for a lot of people. If you found the section 7.1 difficult, you're probably going to find section 7.3 difficult. But there's been a lot of you out there have come to me and said, I don't understand what's so hard about this. Because all you're doing is just memorizing the rules, right? And I think I've talked about this before. Section 7.3 and even 7.4 is a lot of just memorizing the rules and applying the rules. So let's talk about the rules for multiplication. Now, one of the things that people struggle with is knowing when things are fully simplified. So let's talk about when an exponential expression is completely simplified. Now, here's when it's fully simplified. There are no negative exponents. You know, we talked about this back in section 7.1. You can't have negative exponents within your answer. They're not happy. You got to move them. The same base does not appear more than once in a product or quotient. That's going to be key for today. You cannot have the same base in a product or a quotient. So in a multiplication or a division. Okay. No powers are raised to powers. We'll learn how to simplify that today. No products are raised to powers. We're going to learn how to simplify that. No quotients are raised to power. Remember, quotient means division. We're going to talk a little bit more about that in section 7.4. And then I can't have any numerical coefficients in a quotient that do not have any common factor. And we'll talk about what that means here in a second. But let's take a look at some examples of when things are simplified and when things are not simplified. Now, let's take a look here. Products of powers with the same base can be found by writing each power as a repeated multiplication. For example, if I wanted to multiply two things that had the same base, notice that this is the same base. Got to have the same base. If it doesn't have the same base, then you can't multiply it. What I can do is I can take that power and actually add them together. Let me show you what I mean here. Isn't 3 to the 5th 3 times 3 times 3 times 3 times 3, right? That's 3 to the 5th, right? This is 3 to the 5th power. And I'm going to multiply it by 3 squared, which essentially is just 3 times 3. This chunk is 3 squared. Well, isn't this all just multiplication? So isn't this really just 3 times 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 3? You get the picture. Well, how many total of them do I have? I have 1, 2, 3, 4, 5, 6, 7 total. So isn't that still just 3 to the 7th? So what did I essentially do with my exponents? Well, I essentially just added my exponents. 3 to the 5 plus 2 power, 3 to the 7th power. And that's what I have. Okay. So that's my product of powers. Product means to multiply. Product of powers property means that if I've got a to the m times a to the m, notice the same base here, a to the m times a to the n is a to the m plus n. I add the exponents up on top. You leave the base the same. Okay, you leave the base the same. The base does not change. Look, x to the second times x to the third is going to be an x to the 2 plus 3 is 5. Okay, how would I, think about this differently? This is x squared is just x times x. X to the third is just x times x times x. So all I'm doing is multiplying in here. I'm just going to take all of those together. That's 5 of them. That's where I get my exponent. Okay, but the quick rule, the shorthand rule, is just to add those exponents together. Let's practice with it. Oh, we just did this. 3 to the second times 3 to the fifth is 3 to the 7th power. And if you wanted to at this point, you could go in and say, okay, what is 3 to the 7th power? 3 to the 7th power is 2187. Okay. More often than not, we're going to be working with variables. So take a look here. What I can do here is combine the things with the same powers, or same bases, excuse me. So I've got a base of 2 and a base of 2 here. So this is 2 to the 4 plus negative 2. I add the exponents up top with the like bases. So that's going to be 2 to the positive second power. And then here, that's going to be 3 to the total of 4 plus 2 power, or 3 to the 6th power. So my final answer is, you could write it as 2 squared times 3 to the 6th, or if you wanted to, you could actually multiply it out. 2 squared is 4, so I'll write that just 4, times 3 to the 6th. So a total of 2916. Okay, I'd be okay with this answer for right now, because I want to know what you can do with in terms of the exponents. See, now this is the questions that are more likely going to appear on a quiz and test. Okay. Now, let's take a look here. I've got a Q and a Q. When I multiply those bases together, because they are the same base, I add the exponents. So I would get a 3 plus 6, which is a 9, Q to the 9th times R squared. And I leave that separated like that. I can't make this like QR to the 11th or anything like that. This has got to be Q to the 9th times R to the 2nd. Okay, notice how I have the same base on all of these. So I can combine this whole thing. So I'm going to essentially take the base of n and add the exponents. 3 plus negative 4 is negative 1, plus, look, isn't that a power of positive 1? So all in total, I end up getting 0, don't I? 3 plus negative 4 is negative 1, plus another 1 is a 0. So n to the 0 is 1. So this thing actually all completely simplifies down to 1. All right. A number or variable written without an exponent actually has an exponent of 1, right? We talked about that just on that last example. Just an x, if it's just written there, just no exponent, you always write a 1 up top. We talked about that a bunch of times. Like 10 is just 10 to the first, and y is just y to the first. So here, look, I've got an m and an m. I'm essentially just combining like terms, aren't I? This has a lot of similarities to that. First power and fourth power make a total of fifth power. And then I've got n to the negative fourth. Now we know better. Can I leave a negative exponent in an answer? No. I can simplify that. Leave the m where it is. The n gets moved down into the denominator. And that's my final answer. Okay, remember, you cannot leave a negative exponent. Let's take a look at one more here. Now notice here, I've got all my same bases. So my final base is going to be another x. What's the sum of my exponents then? Well, I've got 1 plus a negative 1, that cancels. Negative 3 plus negative 4 gets me a total of negative 7, which I have to reduce down into 1 over x to the positive 7th. Remember, you can never leave a negative exponent in an answer blank when we're working with these variables. All right. Now, to find a power of a power, you can use the meaning of these exponents to do so. Like, for example, here, let me just hide this bottom part. If I've got 4 to the third to the second power, you're taking an exponent and raising it to another power. Essentially, what I've got here is 4 to the third times 4 to the third, right? I've got this 4 to the third, this base thing, raised to the power of 2. And how do I raise something to the power of 2? I can just rewrite it that many times, right? This is the number of times of repeated multiplication. So it's 4 to the third times 4 to the third. And this is multiplication, so I can take the base raised to that 6th power. 3 plus 3 is 6. So how did we get there shorter? Like, how would we be able to do that shorter? Well, what's the relationship between 3 and 2 to make it look like 6? We multiply. And that's where the rule comes in. Okay. And again, what we're doing here is we're creating a list of rules that we can follow. So the power of a power, when I'm taking a power and raising it to another power, I have to multiply those exponents. So it's like a to the m. My cat says hi. A to the m times a to the n is a to the m times n. I multiply those exponents up top. So for example, x to the fourth times x to the third would be an x to the 4 times 3 or 12th power. Okay. Let's practice with that now. If I've got 5 to the second to the 4th power, remember, power to a power, we multiply. That would get us 5 to the 8th power. Now I could reduce it down and get the actual number, but forgive me for not doing that right now. You just simplify with the common base, power to a power. Let's keep it going. Anything to the 0 power, oh, that's easy, 1. This also, you can think about it this way, 4 to the, what's 3 times 0? 0, which would get us back to 1 as well. All right, let's keep it going here. Now, I've got 2 properties in 1. Notice how I've got my power to a power property here, right? This is x to the third to the negative 5th. So that gets me an x to the negative 15th because I multiply those exponents together. But then I have this product going on where I'm multiplying the bases, so I would add the exponents. Negative 15 plus 4 is negative 11. And now I have to simplify that. 1 over x to the positive 11th. And that's what you're going to see here is the hard part to all this stuff. You're going to see layers on layers on layers of these things. Okay. So notice that this was a power to a power. This was a product, and then we used our properties of negative exponents. Let's try another one here. Why don't you pause and try to figure this one out? If you can't figure this one out, keep playing, and then we'll watch the answer. Okay, so power to a power, we multiply those numbers, a to the 12th. Power to a power, we multiply those numbers, a to the positive 6th. Now, look, I've got multiplying the bases, so I add the exponents up top, a to the 18th. And that's my final answer. Okay. Another property, the power of products. Okay, powers of products can be found by using the meaning of the exponent again. Like, for example, here, if I've got 8x to the third, well, we just talked about what does it mean to raise something to the third power. You write it that many times in all repeated multiplication. But isn't this all just multiplication, right? Isn't this whole thing multiplication? And can't I change the order and it's not going to affect the outcome? So it's 8 times 8 times 8 times x times x times x. Well, how would we write that? 8 to the third times x to the third. Okay, so what did essentially I do here? I essentially just distributed the power to both pieces of the product on the inside. Okay, you essentially just distribute the power. So let's try that. Or let's look at the actual property here. It says that a times b, I've got a product inside parentheses, and I'm raising that entire product to the nth power. I distribute that n to both terms. So it becomes a to the nth times b to the nth. So looking at this example here, this would take that 4th power and distribute it to both pieces here. This would be like saying 2 to the 4th times h to the 4th. Okay. All right, let's take a look at an example. I take this 2 and I raise it to both pieces here. Okay, that would give me a negative. Look, my negative still sitting there on the outside. 2 squared times y squared. So essentially this 2 squared just becomes a 4. So negative 4y squared. Notice that again, this is going to be one of the most common mistakes that happens. You forget to take the number to the power. You forget to take the number to the power. Don't forget to take the number to the power. Take a look here. Now what's the difference here? The difference is the negative is inside the parentheses. So what I do here is when I distribute that power, I'm actually going to take it still inside parentheses and then distribute the power to both the negative 2 and the y. So this becomes a positive 4y squared. Let's take another one. All right. Now, I distribute this power, and when I distribute this power, look, there's already exponents acting on this thing. So this is really like saying x to the 6th squared times y to the negative 3rd squared. Okay, so we're layering these rules again. This was a power of a product, and now it's power of a power. X to the 6th to the 2nd is x to the 12th. Y to the negative 3rd to the 2nd is y to the negative 6th. This is where we multiply those exponents. Now, I cannot leave this negative exponent on the y, so that the x is happy where it is on top. The y moves down to the denominator, making it a positive 6 power. And that's my answer. Taking a look here, I again distribute this exponent to both parts of my product. I take in negative 5, and then I square it, and then I've got t squared, and then I square it. Negative 5 squared gives me a positive 25, and t squared squared gives me a t to the 4th. Casey says hi. All right, now this one looks big and bad. I encourage you to pause here and write everything out. Make sure you're try it your best, and then we'll play and see what happens. Okay. So the first thing I'm going to do is I'm going to distribute this 4 in here and here. So this is x squared to the 4th times y to the 3rd to the 4th. On the same step here, I can distribute this negative 4 in. So this is x squared to the negative 4th times y to the 4th to the negative 4th. Okay, now I'm going to multiply all of these. X to the 8th, y to the 12th, x to the negative 8th, y to the negative 16th. All right, now what I can do here is combine these terms. Now I'm multiplying the bases, right? The product here, I'm adding the exponents, right? If I'm multiplying the bases, that's when I add the exponents. So this gets me 8 plus negative 8 gets me an x to the 0. I know that'll go away in a second. And then 12 and negative 16 gets me negative 4. All right, so this will cancel. This will go into 1 over y to the 4th. And that's my answer there. Okay. Last problem. The islands of Samoa have an approximate area of 2.9 times 10 to the 3rd square kilometers. The area of Texas is about 2.3 times 10 to the 2nd times as great as that of the islands. So what I'm doing here is I'm going to say, okay, what's the product? If it's that many times as great, what's the actual product? Well, isn't this all multiplication? So what I'm going to do here is I'm going to multiply these two values together. 2.9 multiplied by 2.3, and I get 6.67. And then I'm going to multiply the power of 10 together. Now look here. I've got the same base. So what do I do with my exponent? It's a 2, by the way. What do I do with my exponent? I add the exponents together. And there's my answer. 6.67 times 10 to the 5th power. Okay. Again, I hope we're having a good day. Make sure you spread the word. I am going to be checking these guided notes. So make sure all of the guided notes are completely filled in. Spread the word on that. Okay. Hope we're all having a good day. I'll see you all later.